This is lesson 114. It's on page 460, and it's on nonlinear equalities. We've already worked on linear equalities, and if you recall, when we had a positive slope, the area, the region above the line was y greater than x plus 1. Right, that's a linear function. X is to the first power, y is to the first power. The region or area below the line was y less than x plus 1. Because the line is solid, we would also have used equal to. Remember, the line would have been hyphenated if it was not also equal to. All right? When we had a negative slope, it was the same concept. The region above the line was y greater than, and this would have been a negative slope, say negative 1/2 x plus 2, right? And the line, the region below the line would have been y less than negative 1/2 x plus 2. All right, a parabola, feels different, okay? The area above the line, above this curve rather, everything in here on up, right, is y greater than x squared, okay? That entire region inside the curve is greater than. Everything on the outside would have been, y less than x squared. So we're thinking about going up the y-axis. What happens? Is y getting bigger? Then it's greater than here, okay? Same here. Going up the y-axis, y is always going to be greater than that value of x. When it's open down, remember we have a negative x squared. That's when it's going to be open down. Then this region inside the curve is going to be the y less than the x squared. All the way down, right? All the way down inside that curve, because you're still going down the y-axis. The region on the outside of the curve now becomes the y greater than x squared, because this is the area that's going to go up the y-axis. All right. Now, for a circle, it's a little different. You're going to have x squared plus y squared less than a number. So both your x and your y are going to be on the same side of the inequality. And on the other side of the inequality is going to be your constant. Less than is inside the circle. Greater than is every region outside the circle. So this would have been x squared plus y squared greater than 4. Over here would have been greater than 4. Down here, greater than 4. Over here, greater than 4. Every area around the circle, outside of it, is greater than. Now, when we have a nonlinear function paired with a linear function, it's going to divide your regions into it's going to divide your regions of your coordinate system into about 4 areas. And you have to choose an area that satisfies both, utilizing these concepts. And once we choose the area, then we're going to pick a coordinate point and plug that coordinate point into both of the functions to make sure that our region that we have chosen is in fact correct. All right? So, now looking at example 1 on page 460. Example 1, we have a parabola and we have a line. So the parabola looks something like this. Well, you know, it is Miss Paula drawing it. And then the line looks something like this. Here's my x-axis. That's my y-axis. And then we have these regions, A, B. So C is, I'll draw my parabola down lower. C is outside the parabola, so the greater than area, and yet under the line, so the less than area of the line. And then this region under the parabola and under the line is D. All right, and here's our inequalities. Y greater than or equal to -1/2 x minus 1. And then we have y greater than or equal to, I'm going to leave a little space, y greater than or equal to -x squared. We should have anticipated that -x squared because that parabola opens down, plus 4x minus 1. All right, so greater than the line. What regions are greater than the line? That means above the line. So both A and B satisfy the regions greater than the line. All right? Greater than the parabola is everything on the outside. So the regions that satisfy greater than on the parabola is everything outside of this parabola since it opens down. So that is A and C, right? And so then you ask yourself, which one satisfies both of them? And both of them have A in it. So we're going to choose a point in the A region, plug it into both equations to confirm that, in fact, is the solution. And up here we have the point where x is 0, y is 5. And we're going to plug in 5 for y, 0 for x, and confirm. So 5 greater than -1/2 times 0 minus 1. Well, that's just -1. 5 is greater than -1. It works for that inequality. All right, we'll plug it in to the parabola. So when y is 5, is it greater than the opposite of 0 squared? That's just 0, right? Plus 4 times 0, that is just 0, minus 1. So 5 greater than -1, it is. So A is the region that satisfies both. All right, let's look at practice problem 2. Right on the next page. Now we have our x and our y-axis, and our parabola opens up similar to that. And then we have this hyphenated, let me see where it really crosses. We have this hyphenated inequality for a line, all right? Now, let's look at our equations. Y greater than x squared, y greater than or equal to x, got to be greater than or equal to, right? Yeah, x squared plus 4x plus 2. And for our linear function, it's y, I'll leave some space, y less than -x plus 1. All right, now looking at those functions, let's anticipate the regions. All right, so this region is labeled A. This region is labeled B. C and D is those two areas. All right? Now, greater than, y greater than is going to be everything inside the parabola. So that's going to be A and C. That's going to satisfy greater than in the parabola. All right? Less than on the line is going to be everything below the line. So that's going to be C and D. So which one is in both of them? It's C. All right? So we're going to pick a point inside C, and they have a point. -2 inside C, inside the C region is -2, 1. So when x is -2, y is 1. And we're going to plug that point into both of the functions to see if it works. All right? So when y is 1, is it greater than negative 2 squared plus 4 times negative 2 plus 2? All right, that's 4 minus 8 plus 2. 4 minus 8 plus 2. That's going to be a negative number. That's negative 6. Is 1 greater than negative 6? It is. So that one works. All right. Now when y is 1 for the linear, is it less than the opposite of negative 2 plus 1? Well, the opposite of a negative is a positive. 2 plus 1 is definitely greater than 1. So the region C is in fact the correct area that satisfies both of the inequalities. All right, let's look at example 3, the last example. And it has a circle. So we've looked at a parabola opened up. We've looked at a parabola that opened down. Now we're going to look at a circle, okay? So we have your x and your y axis. And I believe that circle is at 4 with the center at 0. That's negative. All right, so I will draw, well, you know. I will attempt to draw. That is not a very good circle. But I know you're patient with me and gracious, right? And then we have a line. And it is a positive slope. It goes right through the origin. All right, let's look at our equations. X squared plus y squared. Here's our circle. X squared plus y squared less than or equal to 16. And then our line. Y greater than or equal to x. So let's label our regions. All out here is A. All this region out here is A. This side of the circle is B. This side is C. And all out here is D. All right, so less than our equation, less than 16 is going to be inside the circle. So those regions are going to be B and C. All right, y greater than x for our linear function is going to be everything above the line. So this region is going to be A and B. Which one satisfies both of them? B. So let's choose a point in B. And they have this point over here, negative 2, 2. When x is negative 2, y is positive 2. All right? So is 2 greater than or equal to negative 2? It absolutely works for the linear function. Now let's see if it works for the nonlinear function. So we have negative 2 squared plus 2 squared less than or equal to 16. Less than or equal to, all right? So negative 2 squared is 4 plus 4. Is it less than or equal to 16? Yes, 8 is less than 16. So that one works. Okay, work your practice problems and your homework. And that is it for lesson 114.